All right, looking at number 10 from the team round, we have points G and H lie on different sides of regular hexagon ABCDEF, which has side length 12. Line segment GH has length 6 and splits the hexagon into two disjoint regions of positive area, the larger of which is X. Let lowercase m and capital M be the smallest and largest possible integer areas of X, respectively. Compute the smallest over the largest possible integer areas as a common fraction. So let's first draw a diagram to take a look at this problem. Now we have a regular hexagon with side length 12. So we can first calculate the area of the hexagon. The area of the hexagon is going to be 6 times root 3 over 4 times the side squared. Plugging in 12 for the side, this gives us 6 root 3 times 144 over 4, which equals 216 root 3. Now, we have points G and H on two different sides, and because GH has length 6, they have to be adjacent sides. So without loss of generality, let's just say that point G is somewhere on this side, and that point H is then somewhere on this side. Now, we know that the total area of the entire hexagon is 216 root 3. And if we draw GH, say, there, then we can designate an area in here, Y, and then we know that X will be equal to this area, 216 root 3 minus Y. Now, what are the bounds for Y? Well, if we think about it, the lower bound for Y, if we move H or G, one of the points extremely close to the vertex, and then that means that the segment GH will be nearly parallel to the side of the hexagon ABCDEF, then the area will approach 0. So let's say that here we're at vertex F. So that means as either G or H approaches F, then Y approaches 0. So we know that Y is greater than 0, and that's the lower bound. Now, what's the upper bound? Well, to find the maximum area of GH, that happens when G and H are equidistant from this vertex here. We designated it as point F. So if G and H are equidistant from F, or let's put them equidistant from A over here, then we know that with a 120-degree angle at A, then angles AGH and AHG would both be 30 degrees. Now, seeing that right here, with GH having length of 6, the altitude from A to GH will split them into lengths of 3. And therefore, the area Y here, in this case, would be 1/2 times 6 times root 3. So that means that Y is less than or equal to 1/2 times 6 times 3 over root 3, which is equal to root 3, due to it being a 30, 60, 90 triangle. And that means that Y is less than or equal to 3 root 3. Now, we also know that Y is greater than 0. So that means that X, we can now find the bounds for. And using Y, we can bound X being greater than or equal to 213 root 3, but less than 216 root 3. Now, the reason that the bounds not being strictly less than and then less than or equal to is not an issue is because we only care about the smallest and largest possible integer areas. And using a calculator, we can approximate these two to 216 root 3 being just over 374 and 213 root 3 being just less than 369. So that means 369, oops. So that means that lowercase m, the smaller possible area, the smallest possible integer area is 369, and capital M is 374, and that gives us our answer to be 369 over 374, 1410. All right.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.